Okay, thank you. Firstly, I want to also introduce myself and my team, Horia and Alexei. We are covering CE, and we also covering Romania. I'm a system engineer. I'm responsible for presenting a pure solution, but also I know a lot of difficult storage solutions like DellEMC, HPE, Netapp, or hyperconverged infrastructure if you need it. I always could compare it with Pure. Who is Pure? That is very important. We started 10 years ago with a very small startup, and the main person responsible for creating Pure was John Colgrove, who was one of the main architects of Veritas cluster. And he started that startup because of a couple of reasons. And what kind of reasons it was? Something. Okay. Firstly, we have to think about what will be in the future. And 10 years ago, that was obvious that Flash will take over the of the world, and will be main storage media in all enterprise storages. We also know that data will be available and have to be available every time, because no one wants to turn off the production process. Every business process has to be covered by the data. And we also know that 10 years ago and now, the people do not like the storage vendors, the legacy storage vendors, because they complicate all the environment. They have a lot of difficult things to configure, to manipulate performance, to get better capacity or something other. We have to do a lot of work to cover that. And Pure understand that, and Pure trying to address that three things. Firstly, we are covering the NAND module, flash modules, by our technology, Direct Flash, because we are building our flash modules only on the Samsung or Toshiba chipsets, but we provide all the firmware, chipset, everything internally on the flash module. We also know that to move to another platform, to new platform in other storage companies like in DellEMC or HPE, it's always a forklift upgrade. You have to migrate all environment to new platform. With Pure, you don't need it. We design by default in evergreen storage. That means always you have to just swap the controllers. Your production is always online. You never doing something like forklift upgrade or a migration process. And we also know that we have to be a company much more loved by customers, and we measure that every year. And now our score, Net Promoter Score, is the highest on from all the technology companies. Is like 86 and 6 points. That means we are much better. The customers are much better happy with us than with other companies where it's average like 20–30% of all other storage companies. And we're trying to be as much as possible innovative, because the last 6 years we are always from the start, from the first our product release, we are start to be a Gartner Magic Quadrant leader. And in the last year, the Gartner combined two Magic Quadrants to one, one from the flash array and the second from the primary storage, and they combine to one primary storage solution. And we also we are also listed there as a leader. Unfortunately, we do not have new line SAS drives or spinning drives, and it's much harder to compete with our competitors. But it is possible, and I will show it in next slides. And as I mentioned, the infrastructure actually and the storage infrastructure is very complicated, because it's built on the old technologies like SAS, and they covering spinning drives, tiering. They have to address the problems with write, and they calculate the performance based on the write and cache. We are totally different. We are trying to build, or we build something simple, something much more smart than other solutions, and we name it modern data experience, because it's not so complicated to manage that data, but always we have a huge performance from the flash and the properly secured flash with all the future building from ground. What do we have? Actually, we have 4 products, 4 main products. Flash Array X, which is based on the TLC NAND technology, where we calculate like latency and something like below 1 millisecond. We have also Flash Array C, which is based on the QLC drives, and that is a first capacity optimized flash enterprise flash array on the market. And there is we calculate the latency between the 2 and 5 milliseconds for that array. It's not so fast, but it have huge capacity. And we have also FlashBlade, which is a file and object storage. And if we comparing it with a file or object, especially with object storages, most of the object storages are very slow and have huge latency. FlashBlade is like 10 times faster than Amazon S3, and I have also linear performance. That means you just adding additional nodes and you get additional performance. And we have also a last product, which is Cloud Block Store. It's the same like Flash Array series, but it's not based on the typical hardware. It's based on the Amazon hardware. That means we're using ABS S3 in Amazon to create full performance, full featured storage in the cloud. And we also create combined infrastructure solutions with Cisco and then with NVIDIA, and all that kind of solutions are available by our guides. Okay, and To manage that and to monitor that, we're using something like Pure One. It's self-driving storage management, but much more it's monitoring the management, because we could monitor there all the flash array, flash blade, clone block store arrays with all the features included in that solutions. Thank you. What we create with flash array, because I will be focusing on the flash array, and Alexei will focus on the flash blade. Firstly, when we start building that array, we think how complicated is storage world, how hard is configure anything in the storage, how hard is to get right performance from the spinning drive or flash, and what is the different in NAND and spinning drive. We are focusing on the NAND, or only on the NAND. We are not focusing on the spinning drives, and we will never support that kind of type of media. And to simplify everything, we use a lot of automation internal in the array. But to configure that array, you just require knowledge from 2 business cards, where you have like 10 to 15 different commands, how to configure volumes, how to map that volumes to host, how to make a snapshot, how to create replication, synchronous, asynchronous. It's very, very simple. And we build it as much as possible efficient, because we're trying to get the modern type of protocols like NVMe, the modern type of media, and optimize all the stack from the NAND to controllers and the firmware software integrated in storage array. And we also trying to build something to be as much as possible mission critical, and as much as possible supported by our amazing support, which have best scored on NPS score on the market, because it's something like 92%. Our customers are happy because of our support, and we are focused on the customer. That means any customer could create their own requirements for storage, and we will trying to think how we could address that. And we listen to our customers, because they are enabling our sales process. Okay, what we are done internally on the array, I say that we are using the modern NVMe and modern protocols, and all array is based on the NVMe. Internally, on the flash, we could grab any flash cell from the NAND chipset. We could address that internally by the PCI Express switch internally on the shop, and also we could address that on NVMe over Rocky, connecting to disk shelf, external disk shelf. We also addressing all the features internally, like CPU or firmware like Purity, our firmware, who is covering NVMe over Fabric. We also supporting NVMe over Fabric to servers. Actually, it's based on the Ethernet. In the middle of the year, it will be supported also on the fiber channel, because we are waiting for VMware. They plan to support it in the middle of the year. And we also know that the different architectures requires different address of the solutions. Like, you know that you have in your environment Oracle, Splunk, Cassandra, Epic. We're trying to address all that kind of environment on the one array. That means you could put all that kind of solutions, and you just know that you get full performance from Flash. What is the difference between NVMe and SAS? Maybe that first picture will show you what is this SAS. SAS is one connection between the storage, between the CPUs and the storage slots, and you could address here like 8 to 16 commands in one line. In NVMe, it's totally different, because you could address one CPU core to one flash cell, and you have like 256 lines to that in that kind of connection in PCI fabric, and in one line you could address 64,000 commands. That gives you huge performance and huge control of your environment, your flash. How we measure it, because that is important. In old type of array, so we just measure it like QDEP, and unfortunately on the flash array, because of huge parallelism of that array, you don't need to control the number of commands in queue. You just know to how long one command waiting for waiting in the queue, because that command is a lot. And as I mentioned, we create our direct flash modules, and why we are creating our own modules, not to produce, not to buy the modules from Samsung or Toshiba and just put it to storage, enterprise storage. First reason is that mainly the storage vendors using the SSD drives like a black box, because internally in the SSD you have a lot of processes like garbage collector, wear leveling, and another process to keep the flash as fast as possible and healthy as possible. We trying to measure latency to that kind of SSD drives, and it's difficult to control it. It's very difficult to address all that kind of SSD drives by our firmware, and we decide to build our own flash modules based on the NVMe connected by the PCI Express. And main chipset we are using ARM chipset from, I don't know what kind of company, but we are using ARM chipset, and then flash modules from Samsung, Toshiba, Intel, depending on the type of module the type of module. What we get from that kind of module. Firstly, we are covering it our own firmware, and that firmware is very simple. Just forward all that things in on the drive. We also could find the hidden space, because all the flash modules have a hidden space to replace the broken cells, and we see that space internally on the flash. And when you start serving data and you utilize like 100% the storage. You just could write more than 100% of storage array. It means you could write 150% of space of array. The reason of build our own flash is also to determine what kind of latency we have to that module, because we control all the stack and we control what's happening internally on the flash. Any questions? Anything? Nothing? Okay. And in last year we built also based on the QLC drives, QLC modules, our first QLC drive, and that drive is available only on C series, FlashArray C series, but it's the first our QLC module on the market. What do we have in FlashArray? Like 2 weeks ago, we released our new FlashArray, fifth generation, and we replaced something. We done something new in that FlashArray. Give me a moment. Firstly, we just get a new better performance, like 25%, because of we are using new CPU, Xeon Cascade Lake, which is 25% better than previous series, and we also build it truly on NVMe, because in R2 series we build the smallest arrays like X10 and X20 based on the SSDs without firmware SSDs, but now in XR3 we covering X10 and X20 by NVMe modules, and we are releasing new modules for that arrays. Okay, what it look like? Firstly, we have X10, X20, X50, X70, X90. All that kind of arrays are in the same chassis. The difference between all the arrays is in capacity. We supporting in raw capacity like 22 terabytes in the smallest array, up to 61 terabytes effective. That means after the duplication and compression. Each chassis is the same. With difference between the modules, it's only based on the CPU, Xeon, or and memory, and that determine what kind of performance is on the X20, X50, X70, X90. We also supporting something like non-destructive upgrades between the same chassis arrays, like X10, X20, X50. You could upgrade X10 to X50 or X20 or X20 to X70 non-destructively. And you could also upgrade from oldest versions like FA300 series and FA400 series to newest version X10. How we make it? Just connecting by InfiniBand cable, old version in the older chassis, connecting with new controllers, and evacuating all the disks from all the flash arrays to new. And we also have a C series, which is much more focused on capacity, because the smallest version is 366 terabyte row. That means in 3U we have a 1.3 petabyte effective space. In 9U we could have something around 5 petabytes effective space. Okay, when we think about storage arrays and we think what we've done in the 7, 8 years of our development, we adding a lot of new features without any additional cost, because you just buying the subscription for flash array. You're buying flash array as a hardware and support subscription, and we are adding new features in every release. Like in last year we released, last year, 2 years ago, we released something like Snap to NFS or Cloud Snap, or deep compression algorithms, or QoS, or active cluster. All that kind of releases was without any interruption to production, but without any additional cost. Just upgrade and enable that feature. We also change after during that year. So we changed a couple times the duplication algorithm, compression algorithm. We change type of media, controllers, and every upgrade from the oldest version to newest was without any destructive operation. Just upgrade online with working production. Okay. How it looks like. Each array looks the same. X10, X20, X50, X70, X90 have the same chassis. The difference is how many NVRAM modules we have, and how many drives and capacity, what kind of capacity is supported. Firstly, in first chassis and main chassis, we have 20 flash modules with depending of the array. If it's X10, it's maximum 22 terabytes covered by the 9.6 or 11 data packs, 11 terabytes data packs. One data pack is something like 10 flash modules. All that flash modules are addressed by firmware, by software. It's not. It isn't important in which by it's which drive. You could swap it. You could replace any drive to any by. You have also possibility to add to the first chassis data packs, which cover 183 terabytes direct flash. Like in X70 R3, it is possible to build 366 terabyte row space in 3U. That means in effective space, it will be something around 1 petabyte. And we have in that chassis 2 controllers. The 2 controllers could be connected to disk shelves, SAS disk shelves, or NVMe disk shelves. Why we are using SAS disk shelves? Because our previous platforms was using SAS as a connection to disk shelves, and we're trying to be to be connected to a previous version of our storage arrays. On each controller, you have three PCI slots to have fiber channel or Ethernet connection, iSCSI connection. We also have 4 built-in 1025 gigabit Ethernet ports. 2 of them are for replication, 2 could be used for iSCSI. 2 management ports, and it's all. How we are addressing the IOs from the host? Both controllers are active-active. Both ports are active-active on the controllers. That means if you are connecting to a host to flash array, the host will be see all the same LUN for all the paths, like from first controller and the second controller. But only one controller is processing the duplication and compression, and it's writing data to disk. That means in controller, from the controller perspective, it's active standby. From the host perspective, it's active because all the ports are online, and you could write the data for all the ports on array. And the smallest NVM and the smallest X10 and X20 and X50 flash arrays, you have only 2 modules of NVRAM, and the biggest, like X70, X90, you have 4 NVRAM modules. How we connecting SSDs or flash modules with our controllers? Internally, between the controllers and drives, we have a PCI Express switch, and we address all the connection between the controllers and between the flash modules by the PCI Express. Any questions? Okay. Mainly about the hardware is all. What about firmware? Because we build our Purity flash array OS based on the Linux environment, and we enable their couple features like the duplication, compression, film provisioning, but enabled by default. And that is our main difference from our competitors, because we are measuring our space and our performance with enabled deduplication, compression, and film provisioning, and that space is secured by write double parity. We name it write 3D, but it's based on the double parity algorithm, and it's much more changed to address flash NAND cells than spinning drives, because there is a lot of features addressing only flash. Yeah, one question we have on chat. Okay, why we are so important with the duplication? First, because we are doing the duplication the smallest possible block. It's a 512 bytes variable block. Because what's happened if we get that kind of block? We could guarantee the duplication of Oracle or SQL or any other environment where our competitors cannot guarantee that kind of the duplication, because Oracle have block like 8K block, and have two unique things on that block. And if anyone trying to deduplicate it 4K block by 4K block, it is impossible. With us, it is possible. We guarantee duplication and compression for Oracle like 3.8 to 1. We also doing that inline. That means always every data is deduplicated and compressed. Then if array is not so busy, we could compress that second time, because we have two algorithms to compression. First on the front end, very fast, but it's not the best algorithm to compress data because it's fast. And the second algorithm, the slower, but that algorithm covering all the additional features in compression. We name it deep dive compression. It's our IP, and we could get more like 30% more space only on that second algorithm. We also have a replication, snapshot, clones, protection policies, QoS, IO scheduling, everything internally in Purity OS without any licensing. All that kind of features are available, and just you have to get newer firmware, or you have to buy a support subscription to get new features if you need it. The same is with features like connecting array to VMware environment, Oracle, Kubernetes, anything you need it. Just upgrade, or just ask our support to upgrade your array for a new firmware. Then just download connections like vSphere plugin for VMware and use it without any licensing. Okay. That means the evergreen is buy once and stay modern. That you buying once the storage array, and you just using new features with new releases without any additional cost and fees. We also trying to build something all-inclusive. You do not need to think about new licensing models or how to build something on array. Trying to keep it as simple as possible. And mainly, all that kind of features, it will be available on the demo. I think my colleagues from Temperfield will show you on that on demo active cluster or integration with VMware. But I think you could also trying to do that on by self, because we have something like test drive where it's in the virtual environment, and you could build your synchronous replication between the sites and connecting that to small VMware cluster in virtual environment. But it's possible to test it and do some manual things. Okay, what is the active cluster? Active cluster is a synchronous replication between the sites with automatic failover and failback. What we are requiring from the storage perspective. Firstly, of course, we need two pure storage flash arrays with firmware Purity 5.0 or the newest. Actually, it's Purity 5.3.5, I think, the newest. But we are supporting it with 5.0. From customer perspective, from the host perspective, we are addressing typical MPIO drivers. We do not need any additional software, firmware reconfiguration. Just use MPIO driver from VMware or Oracle or Microsoft Hyper-V. It will be okay. Both CITES are active. That means you could write the same host or to the host in the same clusters, in the same cluster, who could write to the same LUN via one active path from the first side and one active path from the second side. Of course, we have more than one active path to both CITES, but I say one cluster could write to both arrays simultaneously. As I mentioned, we need two flash arrays. Could be oldest version, could be different size, like X10 with X90, Purity 5.0 minimal, networking connection 1, 10, or 25 gigabits, round trip time maximum 11 milliseconds, and mediator, arbiter or mediator. It's on our cloud, or it is possible to build an on-premises mediator in your environment. How it's work? First, we are supporting couple different architectures. First, uniform storage access, where first side see both arrays and have active paths to both arrays, and two arrays are writing data to the same LUN. It's uniform storage access, and if one side will fail, the second will get all the paths, and we'll just write data to the same LUN. Nothing happens. With uniform storage access, but with the active non-optimized paths, we have also possibility to configure that on the MPIO drivers on the host, where one path it is optimized, and the host from the one side will write that path, and the second path it's non-optimized. That means during normal work it will be not sending any data, but until failover, when it will be fail one side, we just the driver will just move data the second path, non-optimized path. And fifth, non-uniform storage access, which is, I think, one of the hardest to make it, because we are covering architecture where first side and second side writing only to their own array, and the arrays are replicating data between the sides. And here is huge problems with split brain and that kind of situations with data corruptions. And it's not so simple to covering that by the storage arrays. We are addressing that very simply, because we are addressing, I think, most of the possible failures, like failing the mediator, failing the connection between arrays, and we also addressing possibility to fail a connection between arrays and mediator. That means even if connection will be broken and a mediator will be not available for both arrays, if one of the features, one of the array will be enabled as a pre-elected array, that array will be still online. The second array will be offline. What about mediator? Mediator is a very simple virtual machine if it's on-premise, based on Ubuntu. And a mediator is just answering for the question from the array. First, I am when we'll fail anything like connection between the arrays, arrays will send the packet to mediator and ask who is the first. I am a first or not. If array is the first, will be online. If it's the second, it will be offline. It's very simple passive mediator and build it on the simple virtual machine. Any question to that? Okay, nothing. What do we make it? Well, I say that we could create active cluster between two sites. That's great. But we could also create something like active async. That means we could have the array in the first site, and that array will be asynchronously replicated with stretched cluster arrays. And could we cover the scenario where failover will happen on the both sites, on the both primary sites, and we have to recover from the first site. We create scripts to recover the data from the first site, but it's not automatic. It's much more manual work. But we are showing on our documentation how we could make failover to first site, and it is possible with our technology. I mentioned also that between the sites we are using Ethernet connection, 110 or 25 gigabit Ethernet connection. From the June we will support also fiber channel, and we will support 6th generation fiber channel switches, but we will support a 5th generation of fiber channel switches. We could also make something like light migration between the data centers without any disconnection. Just move data between the racks. Okay, what we could done in our pure TFA. First, flash array could make metro cluster, then snap something locally, secure that data. All the snapshots on our arrays are immutable. That means you cannot change that. You can, even if you delete all the snapshots, it will be not erased until the 24 hours. We are securing that. If you want to erase it and you eradicate that data, you could make it by the additional command, but it's always available. If you have environment where it is possible to attack by ransomware or something like that, and someone encrypt your data on the array, and you make snapshots every day, 1 or 2 snapshots every day, you could recover it from the local snapshot to your environment, because that snapshot will be not changed until 24 hours. Okay, then we have replication, asynchronous replication. We are also building something like near sync replication, something between asynchronous and synchronous. And near sync will be covering architecture with huge network latency, like 30 seconds latency between the two sides. We have also built in array snap to NFS and snap to S3 buckets. What it means, you could send your snapshot to snapshot to Amazon S3 bucket or to FlashBlade S3 bucket, and you could also send your snapshot to NFS, any NFS system in your environment, like Netapp or some kind of Linux NFS export. And we also supporting sending snapshot to Microsoft Azure blob. It's supported from I think last year. And if someone have a cloud block store in Amazon Web Services, could restore that snapshot from S3 bucket to our cloud block store and build your test environment. And we supporting also the Open API for all that kind of snapshot. And we supporting Vim, Veritas, CommVault, other companies. How is make it? I say just to create a cloud snap to Azure or NFS or Amazon, you just need to have a container internal on your flash array. It's not included when you install the flash array. You just sending email to support. Please give me a possibility to give me new app cloud snap for NFS or for S3, and they will deploy it by the remote assist system. Okay, that will be covered by. What else? I say that we don't have any licensing, but we're trying to build something great for our customers. And firstly, we have a couple business models to address that. First, love your storage. Any storage that you will order from Flash, from Pure, you have 30 days to return without any information. Just test it, and if you say no, sorry, it's not for me, it's too complicated, just return. All software is included always, and that is one of the main pillar of Pure. Right size guarantee. That means we guarantee data deduplication, data reduction ratio. That means deduplication compression for applications like VMware, Oracle, for SQL, Exchange, anything you think. I think we could guarantee. We cannot guarantee something for custom application, but it's not so many custom data for custom applications. We also say that it's our support is flat and fair. That means if you buy support and for 1 year, it will be the same price for the next year, and for the next 7 years it will be the same price in dollars. If you will try to measure how much it will be cost in next 7 years, just calculate it by first year or first now. Evergreen maintenance, we always will support upgrade to new version. VMware, we always supporting non-destructive upgrade, and even more, our development are not paying for disrupted upgrades in our environment. Always have to be online without any interruptions. White glove support, we always could create something like estimation and predictive analytics in our support in our Pure One environment. And if you are building our support and connect to Pure One cloud, you just see new cases created by Pure, and we are creating some kind of cases where we investigate on other customers that, yeah, that customer have problem with some kind of drivers on host, and that drivers, because of that drivers, the performance was below that we are expecting. Please change the configuration of the HBA, or please upgrade firmware on HBA, or do something else, because could be better perform with new firmware. And the most important, with our silver, that was in the silver and gold subscription. With gold subscription, we have also something like free every 3. That means every 3 years, when you expanding your support for the next 3 years, you get new controllers, new hardware. That means every time you have the newest technology, the fastest technology with Pure. Upgrade flex, always you in gold, always you paying for difference between the price of the controllers. If you want to upgrade from X10 to X50, you just pay for difference between the price of that controllers. It's only on gold. And the same with capacity consolidation. You're paying for difference in capacity. If you have 10 terabytes of space and you need 40 terabytes because it have to be 4 times more, you're paying only for difference between the in the cost between the flash modules. How it works? Very simple. It's mainly the one box, one chassis, 6 cables, no manual, no tuning. Just install. You don't need to cover any special manual or best practices. It works. The right groups, everything is configured by default. You never see what happened there. You just could configure volume snapshots connecting to hosts, and then you just manage by the FlashArray CLI, REST API, or if you're trying to manage by the PowerShell or GUI, it is possible. Or you could manage by the VMware environment, because we have a very nice plugin for VMware environment. And you could also monitor on your cell phone or your Apple Watch. Everything is possible in Pure. We have also a lot of integrations with VMware, Microsoft, containers. Anything you needed, just write to me or Horia. Everything is very nice documented, and how to connect, how to use it better with Kubernetes or Docker. even more if you need it, if you have a project with Kubernetes or Docker or Oracle, we could covering that by our special engineers, only responsible only for that solution. What we make in Pure One? Pure One is our cloud services in Amazon Cloud. We have there 15,000 arrays, something around trillion data points per day, and something around 7 petabytes space. And we are using Pure One to measure firstly what happened with array. Second, what happened with your own environment if it is something difficult on the port and some kind of errors. We investigate that and we show that for a customer that maybe it is problem with network, some network or something else. We creating based on the Pure One metrics cases for our support, and we also could upgrade array because any array which is connected with Pure One could download newest firmware, and our support will be upgrade that array. We also could measure something like VMware environment with deep dive reporting of that environment, but it's additional feature. And no all the array is enabled with that. And we also have something like workload simulations, where because mainly in the customer, the huge problem is when one of the workloads on array have huge performance and need huge performance, and it is something like noisy neighbor for other workloads. And the hardest thing is how to migrate, and what's happened when we try to migrate that kind of workload to different array. If we will try to migrate that workload to just manually without any simulations, we're just guessing, okay, maybe it will be covered by that array. With Pure One, with our metrics, you could simulate it. You could simulate workload migration from your one array to the second your array, which you both have to report to our environment. Or you could measure what's happened with that workload if you're trying to move from that first array, from older array, to brand new array, to different model of array, and that is covered by Pure One. The same with it is with capacity and performance and hardware upgrades. You could upgrade array, adding new capacity in space or changing the controllers, and you could check what kind of performance will be in new model, what kind of capacity will be on the new model, and what's happened in the future. Okay, thank you.